Now let's take a look at an example. All right. So we spin a yo-yo on a 3-meter string at a linear velocity of 36 meters per second. Okay. How long does it take the yo-yo to make one full revolution? All right. That's our first thing. It's a question about time. And then what is the centripetal acceleration on the yo-yo? Okay. So pause the video now, and then we'll start it here in a second, and we'll go over how we solve this. Okay. Thank you. Okay, so now what we're going to do is actually go through here and actually solve this thing. So let's write down what we know to start and kind of work away from there. So we're given a radius of 3, and we're given the velocity to the tangent of 36.0 meters per second. We know if we go back to our equations that the period, oh sorry, not the period, that the velocity to the tangent is equal to 2 pi r over the period. So now I'm going to solve for the period. So instead I'm going to say that the period is going to be 2 pi r over velocity to the tangent, which means my period then is going to be 2 times pi times the 3 meters for my radius divided by 36.0, which is my velocity in seconds. Okay, and if we plug that into the calculator, we end up getting a value of 0.524 seconds is our value for our time here for our first one. Now the second part asks for what is the centripetal acceleration of this object. Okay, so going to centripetal acceleration, if we go up here and we're solving for that, we still have a radius of 3, and we have velocity to the tangent, which is 36.0 meters per second. We now also know the period, which was 0.524 seconds. Okay, so we could solve it one of two ways. We could solve this using either one of the equations that we were given, because we know the period, we know the radius, we know pi, we know the multipliers inside there. Okay, so we could use acceleration centripetal is velocity to the tangent squared over r. Or we could say that the acceleration centripetal is 4 pi squared r over the period squared, because we have all the data to do either one. Well, I'm going to do this one because it's less work. It's less things to worry about. So I am not going to use this one to solve this one. Okay. Instead, I'm going to use that. So my acceleration centripetal, my velocity is 36. I'm going to square that, and I'm going to divide by my r, which is 3. This is going to be in meters per second squared. This is going to be in meters. So ultimately, those are going to cancel, and I'm going to get an answer of meters per second squared. So all I need to do is take 36 squared and divide that by 3, and I get an acceleration centripetal of 432 meters per second squared. Okay? And that is actually a pretty realistic number. Okay, so we're going to find really big accelerations. This is not working at all for me here. We're going to find some really big accelerations for our things that move in circles. Okay, circular motion creates a lot of change, and that a lot of change is felt by us. Okay, so if you've ever been on any roller coaster or any amusement park ride, they purposefully move you and accelerate you way past the factor of a single g to create that that feeling of excitement as we go around things. All right. So those are our first two practice problems. Okay. Let's go through another one. You want the yo-yo to travel 1 revolution every 2 seconds. Okay. So same yo-yo, but we want now we want to move it so it travels at 1 revolution every 2 seconds. So what's the tangential velocity it's moving, and what would the centripetal acceleration be? Okay, so same idea here. Let's pause it, use your equations, and try to solve it, and then we'll come back together and we will work it out. Okay, so now let's solve it. All right, we have the same yo-yo. So having the same yo-yo, we can say that the radius is still 3 meters. All right, so that hasn't changed here. But we now have 1 revolution every 2 seconds. So it moves around a revolution 1 time every 2 seconds. So that would be our period. So we have a 2-second period on this thing. Okay. Now looking for that tangential velocity. We know that velocity to the tangent, that was like an F, tangent is equal to our 2 times pi times the radius divided by the period. So velocity to the tangent is going to be 2 pi times a radius of 3 divided by a period of 2 seconds. Okay? Well, I have 2 and 2 in here, so really my velocity of the tangent is just 3 times pi. Okay? So I just take 3 times pi, and my velocity to the tangent is now equal to 9.4, looks like 3 meters per second. Okay? That being my velocity to the tangent there. Okay? That's the first part. Second part, what's my centripetal acceleration now? Okay, so we know my velocity is 9.43 meters per second. What's my acceleration? And again, acceleration can be solved by velocity tangent squared over my radius, or it can be 4 times pi squared times the radius divided by my period squared. Okay, so either one of those equations still works. In this case, I'm going to choose to not use this one, and instead I'm going to use this one. Okay, so in that case, I know it is 4 pi squared. My radius is 3, and I'm going to divide it by my period, which was 2 squared. Well, nice for me, 2 squared is just 4. So 4 and 4 cancel out. So now, to find my acceleration, all I'm really doing is taking 3 times pi squared. Okay? So pi squared is 9.86 something. Take it times 3, and I get an acceleration centripetal of 29.61. I don't need the 1 in there. Just need the 6. And that is in meters per second squared. Okay? So it was pi squared times 3 is all I did to get that one. All right? There'll be more practice for you guys in your homework for this stuff. But these are equations and kind of how we use them. In the next video, what we'll do is go into this idea of, okay, what's causing all this? Okay, what's causing the acceleration? What's happening with the velocity? What's happening in which, of course, is a type of force. Thank you.